if I have, I know I've drawn the B field a million times already, and you're kind of bored of the B field. I get it, I get it, I get it. Okay? But now let's assume, okay, on this B field, we're going to have a wire that looks like this. Okay, we're going to have a wire that looks like this. This is my wire. This is my wire. What are you doing? David, have you had your mom for a teacher yet?
Have I?
Yes.
Yes.
Did you behave the same way in her class?
Yes.
You know my dad's a teacher, right?
I do.
And I had him too.
Yeah.
And the rat gave me a B. I was so ticked. I still to this day bring it up to him.
I bet your dad
Is hardcore. All right. Let's say, guys. Let's say I'm gonna label this. I'm gonna label this 1 and 2, each side of the wire. Okay. And let's say I have a current coming through the wire like this. What is the direction of the current on this leg right here? Which left? To the left, right? What's the direction of the current on this leg? North. What's the direction on this leg?
Right.
To the right. What about this leg over here?
Right.
What about here? Okay, what about here? Okay, and here? Okay. All right. Now that we've got that, now that we have that, let's do our right-hand rule. The right-hand rule where we have, again, we've got this. Wait. Okay. Where if this is my I, okay, this is my B, right? Well, it's the same thing, guys. F, right? Right? IBF, right? Okay, right-hand rule. Right? Okay. So, if that's the case, what direction for this leg right here, what direction is the force? So, how do I draw a vector? How do I draw a vector that goes into the wall? Circle and an X. That was really horrible. Let me draw it again. Circle and an X. Now, what about the other side?
It's going to be just a circle out of that.
Is it coming out of the page or into the page?
Out.
Out. And you draw with a circle and a dot. Okay? Everyone with me? Yes, yes. Okay. All right. What I'm going to do... Okay. I'm going to... Okay. But now, I'm going to erase some stuff. Shh. Quiet. Okay. So now here's the thing. From here to here, what I've done is I've flipped it 180 degrees. Okay? So this is 2 and this is 1. The reason I did that, right, is if I have a wire like this, here's my wire. TV magic. Okay? That's the wire, right? It's going to want to do this, isn't it? It's going to want to flip all the way around, right? So it's going to want to take, and it's going to want to come and do this. like this, right? It's going to want to do a rotation like this, right? Okay? So once it's flipped 180 degrees, what was wire 1 and wire 2 is now wire 2 and wire 1. Okay? Let's assume, guys, for a moment that I don't change the direction of the current on the wire. If that's the case, on this side, what direction is my current going? On this one, it's going right here. It's going down. What about here? To the right, right? I'm glad you know east and west. It's good. It's a good. No, it's good. East, yes, right. But okay. Okay. What about this one here, guys? Down. What about this one here?
West.
Right. What about this one?
West.
Right. What about this one? And what about this one?
North.
And this one? To the right. Okay. Now, given this, what is the direction of the force on the left vertical part of the wire? Is it going which direction? Everyone?
It's going one direction.
It's going right at
Okay, do the right hand rule, guys. Guys, if you haven't done this and you're uncomfortable, this is a time to practice. Okay? So that means it's coming out at you, right? What about this side? The right into the page, right? Okay? So that means it's trying to spin it what direction?
It's trying to the opposite.
It's trying to go the opposite direction, right? So it's trying to do one of these guys.
one of those. Those are really good arrows.
Thank you. All right. I did it again. I did this last time too. I do that. It's such a great arrow that I screw it up. It's such a great arrow that I go the wrong way. I don't know why I do that. All right. Shh. Right, doing this. Okay. So now, okay. Here's how this works. So, let's say I have a box. Let's do this. Okay. And let's say I have a big circle in the box. Oops. One more time.
Center it. No.
What's that?
This is where it's like.
What's that? Yeah, smart.
Yeah, I am a little OCD.
That's just good to draw.
Okay, and let's say I do one more. Okay.
Oh, geez, that's actually really
It looks like a kid.
It's easy.
I started midnight, so I slept when I started. It was a good movie. That movie
All right, now. So what I've got is I've got two magnets, a north and a south, right? Okay. Okay.
Yeah,
What?
we gotta draw this.
I'm hopefully gonna record this.
But it takes a while to draw.
You did that really good.
Did you take a few art classes?
Just a couple.
Boom.
I see.
You have to communicate, and drawing is a great way to communicate.
It really is.
Okay. Okay. So now I've got I've got the B field here, right? I'm going that direction, okay? North to south, right? Okay. Now, here's the thing. This represents our motor, all right? But what I've also have is I've got the centerpiece, right? Okay. All right. And now what I have is I'm going to simplify the motor into one line, okay? So let's say I have a green, I'm going to represent with a green wire. All right, let's say the green wire is here. Here's the represented green, it's called a green wire, okay? Yeah, it is a thick green wire, that's correct. All right. All right. So it's as if I've got one wire, this same wire is wrapped around the cylinder, okay? Oops. Same green wire is wrapped around the cylinder, okay? So the rest of it, there's no wire. Let's just say there's no wire in between, it's just one wire, okay? Now, what I can do, okay, is I can take and create a contact here and here, okay? And let's say that contact hold on one second. Like this, right? So I've got, what side is over here, guys? What is this thing right here? Okay, what's this side here? What's this side here? So positive here, negative here. Okay, so here's the thing. I'm only going to get current to flow through the wire when the green is aligned with the gray, right?
Okay.
I'm only going to get that to happen. So when it's aligned, I've got current going positive on. God, I poke my eye out. I really am.
Poke your eye out.
Yeah, I know, right? So we got the positive here, negative here. So the current's flowing in this direction, right? The current's flowing in this direction. I'm going in here. What's the direction it wants to rotate? If this is positive, this is negative on this side. Let's say the green wire is horizontal. What's the direction it wants to rotate? Let's do this.
This way. Hang on.
Okay, so current is going
Wait,
into
where's
the wall.
Wait, where's current go? Okay, current's
Well, you tell me. Positive here, negative here. It's going to go from this all the way around. Assume that this is turned like here.
Clockwise.
Okay, assume that we have. I'm going to draw a wire here for a second, like right here, really lightly. Here or here. Well, let me come back. Let's say, for instance, it's right there. Okay, that's an option. All right. When the wire is here, okay, what direction is the current going on this side? On this side is what? Let's say the wire's going into the page, right?
Yes. Yeah.
The current direction is down the cylinder, right? Does that make sense? Because again, it's going to go. If this is positive, negative. The current's going to go positive to negative. So current's going in this direction, right?
Yeah.
So if a current is going in the direction, which direction is my B field going?
To the right.
To the right. So which direction is my force going?
Yeah.
Down. So am I trying to get my motor to turn clockwise or counterclockwise?
So it's easier to show like that.
In this case, what am I trying? Counterclockwise or clockwise? Everyone? Does everyone know counterclockwise?
Yes.
So I have a force. So now I'm going to have a force. I'm going to have a force.
No, Trip, you're using your left hand.
Oh man.
Right? There's my force, right? There's my force. Right, guys? Shh. There's my force, right?
Your force is going down.
On one side going down, this side's going what?
Up.
Right? So I'm creating a what? A torque, a twist. And we'll talk about torque in a second. I'm going to create a torque. So I'm trying to make it rotate what direction?
Counterclockwise.
Counterclockwise. I'm trying to make it rotate, okay?
That's so embarrassing.
in this direction. Right? Try to make it rotate all the way around. Now, once this wire gets over to here, and this wire gets over to here, do I get a different force set up? No. Do I get the same force direction? Right? If this is my pin 1, pin 2, pin 1 initially has what on it? Positive or negative?
Positive.
Okay? When I flip it to here, what does it have?
Negative.
Negative. So is my current now changing directions on the specific wire? Yes. But it's staying the same direction relative to the magnetic field.
Yeah.
You follow me? So I'm continually having this continuous torque in one direction. Now notice, by the way, once the wire moves away from the contact, do I have any current? Once the wire moves away from the contact, do I have any current? No. But I have enough rotational momentum to get beyond that gap to the next one. Does that make sense? Everyone with me? You see how this works? Okay, let's look at how it works in the real world. Going. All right, so we've all gotten to work with motors, right? We've used these motors before in our robots, correct? Okay, and we talked yesterday about how the motor worked to a certain extent with wire having current running through it in a field where it would rotate, right? We talked a little bit about that. So what were the things that we had to have? What were the two basic things that we had in that motor configuration from yesterday? Okay, we have, how many magnets do we have? Two. Why do we have two? One above and one below so we can create a magnetic field that goes up, right? So here is a motor taken apart. Now they're all the same. Okay? So here we've got a motor sort of taken apart, and you can see inside here a couple of things. You can see this thing right here. What is this right here? What is this? Okay, it's wire, right? And at the very end of class yesterday, I talked about looping the wire, right? Looping the wire. Did I talk about looping it? I'll talk about looping it in a second. So we can loop the wire, all right? And you'll notice this thing right here. Right here, guys?
What is that?
You tell me, what do you think this is?
Magnet.
Ah, it's a magnet, right? What about over on this side?
It's another magnet.
It's another magnet, okay? So I'm going to pull this out. Now, I want you to notice this end looks just like the end of your other motors, right? You see that? This end here? Watch what happens when I pull it out. Like this.
Oh no.
Okay, so it's literally attached to the wire. Okay? Now, in here, you're going to see again one magnet and one magnet. Okay, I know they're magnetic because again, it can hook up a paper clip, and it's definitely magnetized, right? Okay. Here's a quick question: if this is the north side here, what is this side over here? South side, right? So we have to have a continuous direction of field in one direction, right? Okay. So this is the motor. We've got these windings in here. We have this wire. And I'm going to come back to this in a little bit, probably at the end of the class. But you can see the wire is actually attached to this metal structure right here. Okay? And you notice as I spin it around, it's also attached to this other metal structure, and there's a gap between them. You see the gap? Okay, and there's actually 3 of them. All right, and we'll see why in a minute. And I'll talk to you about that in a second. And then these guys are actually just pieces of chunks of iron, and they're meant to spread out the field. And again, we'll talk about that in a little bit. It's essentially creating an electromagnet in here, and we'll talk about how that works in a minute. So now that you can kind of see, basically what's happening is that when that wire is rotating, we're rotating the entire axle, which is what sticks out the bottom of the case, which in your robot you were able to actually move stuff around. Does that make sense? Okay. And now if I look at this again, you'll notice that I have a contact and an insulative non-contact gap, another insulator, right? But what's opposite of what I showed you before is that actually the gap is really small and the contact area is really big. Do you see that? So by doing, and I actually have, this time rather than having 2, I actually have 3. And that way I can get more, if I think about my sine curve, remember we talked about the sine theta, right? The force is from 0 to 100%. I can try and divide that curve and get the maximum amount of force I can so that every first third of that curve, I'm going to get that P. So I can think about getting a portion of my curve. What would normally be this, I get a third of that, and I can continue to hit it and hit it and hit it.
So it's more powerful.
More powerful, exactly. And the amount of time that I spend not providing power from the current is very, very small. Do you guys see that? So this is how your motor works. This is how your electric and all electric motors work. Now, we'll talk tomorrow about what this thing is doing and how this works with the coils. I'll do that tomorrow. Remind me about that. But does that make sense? All right, good.